All right, so part two here. We're going to find the derivative of f of x equals square root of x. Then we're going to find the slope at these 2 points. So if we put this in here, we're going to have the limit as the change of x goes to 0, so that's all the same. Being the square root of x, that's going to go to the square root of x plus change of x minus the original of minus square root of x all over change of x. So right now we can't do a whole lot because our change of x going to 0, we can't cancel it on the bottom, so that's going to make the bottom be 0. So we're going to have to rationalize this. So we're going to times by its conjugate of square root of x plus change of x plus the square root of x over square root of x plus change of x plus square root of x. So we did that in the past when we were rationalizing the denominator or numerator. Remember, when it's 2 terms, we have to do the conjugate that we're going to times by. So what we have here is, well, the first and the last times each other as our limit of change of x goes to 0. Remember, these middles, one's minus, one's plus, so the middles aren't going to matter. We just have to take the first ones and then the last ones times each other. So we're going to get x plus a change of x for these 2 times each other. The last one will be a minus x all over change of x times square root of x plus change of x plus the square root of x. So we can start canceling this. The x's are going to be gone. So we would have the limit as change of x goes to 0 of change of x over change of x times the square root of x plus change of x plus square root of x. So yeah, we can cancel more and get rid of these change of x's, leaving us with the limit as the change of x goes to 0 of 1 over square root of x plus change of x plus square root of x. So when we put this in here, that's going to make that disappear because that would be 0. So what we're left with is 1 over, we have a square root of x and a plus another square root of x, so 2 square root of x. And from here on out, we now have our equation that we can find their slope with. So if we put 1 in there, we would have, so let me do f prime of 1. We 1 over 2 square root of 1. Well, square root of 1 is 1, and 1 over 2 would just be a half at that point. That would be our slope. If we did f prime then of the other one of 4, we'd have 1 over 2 square root of 4, which square root of 4 is 2. 2 times 2 is 4, so we'd end up with 1/4. And that would be our slopes. Find the derivative with respect to t for the function y equals 2t. Now, the book likes to put t's in sometimes for our variable. If that throws you off, just make it an x, and it'll still be fine. So, limit as change of x approaches 0 of 2 over, we're going to do x as x plus change of x. We're going to sub that in for the t. Minus 2 over x. And this is all over a change of x. So when we're dealing with fractions and side fractions, we're going to do leave change opposite. So this is going to become the limit as the change of x approaches 0 of 2 over x plus change of x minus 2 over x. And the whole thing will be times 1 over change of x. Because we're going to leave the top alone, change from division to multiplication, and then flip the bottom one over. Now, from here, we need to get a common denominator, which is going to be, so limit change of x goes to 0 of x times x plus change of x. Now, because we're timesing by this here, we're going to have the change of x on the bottom there anyway. So this first one's missing an x, so we'd have 2x there. Minus, the second one's missing an x plus change of x, so if we distribute the 2 in, we minus 2x minus 2 change of x. So 2x and a negative 2x, those can cancel. And so we're now, let me actually put this up here. So we would now be at the limit as change of x goes to 0 of a negative 2 change of x over x change of x times x plus change of x. So we can cancel this one, cancel that one. So we'd have the limit as change of x goes to 0 of negative 2 over x times x plus change of x. Well, as change of x goes to 0, that's going to wipe this one out. So we're just going to have x times x. So we end up with a negative 2 over x squared. So if we want to put our t back in there, we'd really be at negative 2 over t squared. And that's how it's going to go. So when finding continuity of a function, alternate limit we can use, we can do f prime of c equals the limit as x approaches c of f of x minus f of c over x minus c. So a lot of times we will more so use the difference quotient in this. Not so much using this one, but the x's would stay, and then you would put the c's in, and that would also reduce it, and then you would find as x goes to c what's going to happen. Because you're still trying to get this to be nothing, the difference between the x and the c. So that's why we want x to approach c and that stuff. As long as the limit exists with this, both one-side limits must exist. So we would find it with the left side first, and then we would find it with the right side, show that they both exist. And they should be the same thing, otherwise it's not going to be differentiable there. Also, if the function's not continuous at c, so for example, if we're looking at the step function here, there's jumps in here, so it's not continuous everywhere. So there's not going to be a derivative for this. This one will not work. So as long as we can find the derivative of it, we know we're going to be continuous. So there's not going to be jumps, gaps, skips, holes, anything like that. However, going the other way, if we know it's continuous, doesn't always mean it's differentiable. So if we look here at the function absolute value of x minus 2, if we do that other way, we'd find the left side first. Well, f of x minus f of 2 over x minus 2. So absolute value here of x minus 2 is our function. If we put 2 in there, 2 minus 2 is going to be 0. So we're going to end up with the absolute value of x minus 2 over x minus 2, which will be a negative 1 in this case, because if we're on the left side of 2, we're less than 2, so we're going to subtract more than what we have, which would make the bottom be negative. The top being an absolute value will always be positive, but you would have a negative 1 then. So same thing over, which we reduce down to a 1, but this is positive, this would be negative, makes a negative 1. Going from the right side, same idea, only we have more than 2 here now, since we're on the right side. So when we subtract, we'd have positive on the bottom, positive on the top, we'd have positive 1. So our each sided limit, we're able to find it, but they're two different things, so therefore it would not exist at 2. Anywhere else on here, we would be differentiable. And even though this is continuous, there's no gaps or anything, our limits do not match up. So won't be able to do the derivative when x equals 2 then. That one won't work out. Last couple things. So the function f of x equals 1 over x to the third is going to be continuous. So as we see this curve, there's no gaps, no jumps, no holes. However, at 0, we're going to be vertical here. So it's going to go to infinity. And remember, there's no derivative when it goes to infinity, that limit. That limit wouldn't exist. So our last thing here in theorem 2.1, which differentiability implies continuity. So if f is differentiable at that point, then we know it's continuous at that point. So that's kind of what we've been talking about that last little bit. So Let me know if you have any questions, and we'll talk to you later, guys.